Hello and welcome to my video, lesson 4.3 on the quadratic formula. So this whole unit is about solving quadratics. The first part we looked at solving by graphing, second part solving by factoring, and now we're going to look at using the quadratic formula to solve. And what's beautiful about the quadratic formula is you don't need a calculator because you can leave it as an exact value. And you don't need a calculator because you also don't need to graph it. But you can use quadratic formula when you have no idea how to factor it. So you can definitely use this when you don't know how to factor and you don't have a calculator. So let's take a look. And one thing to keep in mind when you don't know how to factor, oftentimes like if a is some big number, like bigger than 3, if a is bigger than 3, you're going to often use quadratic formula for that because it's just too hard to factor. So there's just a weird formula, crazy however they came up with this, but there's just a formula here where if you plug in the numbers a, b, and c, a, b, and c, those are the two coefficients and the constant, into those different positions, you will get the answer, or the zero, or the solution, or the x-intercept for x, the value of x. Alright, so if we just notice something in here, we have a little plus minus thing going on. We have a plus minus in our equation, in our formula, and that plus minus means that if we look at the thing afterwards, it's actually in a square root, which means that we call it our discriminant. I'm going to actually erase that. Huh. There you go. That was weird. It wasn't erasing. But anyways, we call that our discriminant. Okay? And if that thing inside the square root is a negative number, okay, you can imagine if that's a negative number, -1, right? Then square root of -1, you don't know how to do that yet. Okay? So eventually, like in university, you'll figure out that that's that's an imaginary number. So when we've always written down like, hey, x is in the real numbers, right? I is not a real number. It's an imaginary number. Okay? So anyways, if it's negative, then that means, right, if our discriminant is negative, if it's less than 0, there are no solutions. Alright? But there are two solutions if it's greater than 0, and there's one solution if it is exactly 0. Okay, and I'll just write that it has to be exactly 0. Okay, very important. Okay, so, well, let's go ahead and try this. If you are able to right now, pause the video and plug in those values into your calculator and solve for x. All right, I'm going to try this out. All I'm going to do is literally write x equals, and I'm going to put a negative b. b is 6. Okay, I'm going to put a plus there for now, and I'll put a minus there in a second to try the same thing after. -6 squared, make sure that's in brackets, otherwise the negative stays. But because we're squaring it, it's going to be negative times negative, so it becomes positive. So make sure you have that in brackets. For a... Wait, why am I putting negative? Negative in the first one, not in the second one. What am I talking about? Whatever, I'll still put it in brackets. I made a mistake. Here there's a negative, but here there's no negative. So I don't know what I was doing. Anyways, a is 4 and c is 2. All over 2a, which is 4. So what value are we going to get if we plug that into our calculator? -6 plus 6 squared minus 4 times 4 times 2 over 2 times 4, and we get a negative 1/2. All right. And what if we switch that whole thing and we make it, instead of adding the square root, we are subtracting. Oops. Just plugging in my calculator. So x equals -6, right? And you just do the whole darn thing again, except you put a negative here. So I'm just going to write it out this time, but normally I wouldn't write it out twice. Normally I'd only write it out once and just put a plus minus. But anyways, if we do that whole thing in our calculator, we get -1. So, looks like we could have factored this one, turns out, because those are actually pretty straightforward numbers. And if you would have factored, you would have gotten x plus 1 and x 2x plus 1. Oh yeah, I guess because you could have taken out a greatest common factor, so greatest common factor of 2. There you go, makes sense. We could have done that by factoring. But we didn't. We didn't have to. We could just do it with quadratics. Alright, let's try this next one out and see if it's the same sort of thing. So, like I said before, I would normally just write plus minus and -3 or -3 and just fill in the whole thing. So 2 times a, which is 2, 3 squared minus 4 ac, which is -2. And because it's plus minus, we're just going to try it twice. So I'm going to start by doing the plus version. Oops. -4 times 2 times -2. Two times 2 at the bottom. And we get 1/2. And what if we tried it? We're going to be very similar numbers as before. What if we tried it with a minus instead of a plus? Then we'd get -2. There you go. So our two answers, again, we can put this back into a factored form if we want to. We don't need to, but we can. So x plus 2 and 2x minus 1. So if we wanted to have it in factored form, we could. But anyways, either way, our answers are -2 and 1/2. And for this other one, we were at -1 and -1/2. Which we got just from solving the quadratic formula. I hope this video helps, and good luck.